Hello and welcome back to the course. In this lecture, we're going to talk about the cross-entropy loss. Now, the cross-entropy loss is usually used for classification problems. When you want to classify a given input. So let's say you have a task of classifying whether an image is a cat or a dog or a boat. Let's say you have three classes. So in this case, you'd use the cross-entropy loss. This is a classification problem. So the cross-entropy loss penalizes probabilities of correct classes only. So basically, the loss is only calculated for correct predictions. If you relate it to the binary cross-entropy loss, then basically we're only taking this first term right here. So the actual labels should be in the form of a one-hot vector in this case. Now, a one-hot vector means a vector with a value of 1 in the index of the correct class. So let's say you have a classification problem and you want to classify 4 different classes. Okay, so that means you have 4 labels. Now each label is basically a one-hot vector. So for the first class, the correct label is 1, 0, 0, 0. For the second class, you have a 1 in the index 2. Okay, so 0, 1, 0, 0. For class 3, you have 1 in the third index, so it's 0, 0, 1, 0. And for class 4, it's 0, 0, 0, 1. Okay, so this is how your labels should be. They should be in the form of a one-hot vector. So if the label is wrong, that means the label is 0, then you have no loss calculation. And if the label is 1, then you have a loss calculation. So if we consider this equation right here, when the label is 0, that means yi here equals to 0. So basically, this whole thing gets cancelled out and you won't compute the loss for wrong classes. But let's say that you're calculating the loss for the first class. So the first class, which is 1 here, basically you're going to multiply 1. So yi here is 1. And then you're going to multiply it with log of your probability. Okay, so at the end, you just have log of your prediction for the first class. And all the others here are 0, so you're gonna multiply everything here with 0. Okay, so 0 times log of the predicted probability for the second class plus 0 times log of the predicted probability for the third class, and finally 0 times the log probability of the fourth class, the predicted probability of the fourth class. So basically, all of them we're just gonna cancel out, and you're gonna only be left with the log of your probability of the first class only. This is when your actual label is class 1. Okay, so this is when you have a 1 here. When you have when the actual label is class 2, then same thing, everything is 0 except for the second class, which is a 1 here. So you're gonna take the logarithm of your probability for the second class only. This is how the cross entropy works, and remember, we're also taking negative of the log, so that's why we also have a negative sign right here. So at the end, loss is only calculated for correct predictions, where the prediction should actually be. You're considering only the place where the prediction should be. So for example, in class 1, you're concerned about the probability for this place right here. For the second class, you're concerned about the probability for this place, and for the third class, for this place, and finally for the fourth class, in this place. So in other words, you don't really care what your probability is for the wrong classes, because you're only calculating the loss for the correct classes. So let's take a practical scenario in order to comprehend the cross-entropy loss better. So suppose we have 4 different classes that we want to classify. Okay, so for a single image, we want to classify this image into 4 different classes. Let's say that the 4 classes are cat, dog, bird, and cow. Okay, so we have 4 different classes that we wish to classify a single image into these classes. So suppose that the ground truth or the actual labels are 1, 0, 0, 0, and the predictions after softmax are 0.1, 0.4, 0.2, 0.3. So realize that all of your predictions sum up to 1. And in this case, for this single image, the first class is the correct class. So this is our labels. There's a 1 at the index of the first class. That means the first class is correct. Okay, so what we want to do is penalize the prediction of the first class only. So the prediction is 0.1 and we want it to be as close to 1. Okay, so 0.95 would be great, for example. So if we apply the cross entropy loss, then we're going to take our actual label. So let's just follow this equation. So the actual label yi is 1, and we're going to multiply it with the logarithm of our predicted probability. Okay, so the predicted probability is 0.1. Okay, so log 0.1. And now all of the others here are 0. So that's why we're actually ignoring the loss for the 0 labels. So the loss doesn't depend on the probabilities for the incorrect classes. So for these, all of the labels are 0, so you're just going to end up multiplying the logarithm of the probability with 0. Okay, so they're all going to go away. So actually, it doesn't really matter what these predictions are because we're not penalizing them. We're only penalizing the prediction for the correct class. So in this case, the cross entropy loss after calculation, and of course don't forget the negative sign, which is outside here as a common factor for all. Then at the end you get 2.3, so the loss is high. In this case you want to minimize this loss, so when you update the weights to minimize the loss, then this prediction will become closer to 1. So sometimes the cross entropy loss is averaged over the training samples n. Okay, so n here is the mini batch size if you're using mini batch training, and if you're not using mini batch training, then n is just the complete training samples. Okay, so at the end you compute the loss for all the samples and you then just take the average, so you divide it by n. Okay, now let's take an example when the prediction is almost correct. So the ground truth labels, again, 1, 0, 0, 0. So for in this case the first class is correct since we have a 1 here, and the predicted labels are 0.9, 0.01, 0.05, 0.04. So as you can see, 0.9 is close to 1, so it's almost correct. And if we calculate the cross entropy loss, we're going to get 1. So this is our correct label, which is 1, times logarithm of your predicted probability, which is 0.9. So it's just basically logarithm of your probability. So log 0.9. And of course, taking the negatives, of course, with the negative sign, you'll get 0.04. So in this case, the loss is low. That means we have a good prediction. The loss has reached the minima, and the weights have been updated as expected. Okay, so I hope you can understand the cross entropy loss by these examples that we showed you here. Thank you very much. That's it for the cross entropy loss. I'll see you next time.